Welcome to Marshall Space Flight Center. I'm Shannon Ridinger, and I'm a Public Affairs Officer here. And today, we're so glad you are all here. We are excited to announce the work the Center is going to be doing with Sierra Nevada and Teledyne Brown. So now I am going to introduce our panel. They're going to be telling us more about this expanded collaboration. So the first person on our panel is Paul Gilbert, and he is the Deputy Manager for Flight Programs and Partnerships Office here at Marshall. And then we have Mark Sarangelo. He is the Corporate Vice President and Head of Sierra Nevada Space Systems. Then we have Rex Jevedon, and he is the Executive Vice President of Teledyne Technologies. And then we have Mark McLeay, and he is Chief of the Advanced Planning and Integration Office for Marshall's Mission Operations Laboratory. So now I'm going to turn it over to Paul, and he is going to talk about flight programs and partnerships.
Okay, thank you, Shannon. Good morning, everyone. I'm Paul Gilbert. I'm the Deputy Manager for the Flight Programs and Partnerships Office. And as you can guess from our long title, part of our office contains partnerships, which is an organization, I call it external facing, and what it does, it tries to help industry and the community when they need to get access to Marshall's unique capabilities. So a little bit like the help desk at the mall. Where do I go? I need something. How do I get it? What is it? So they're the help desk that comes in. We're here this morning, though, because we're very proud. Part of the work we do is to support commercial space, a big initiative of NASA and the administrations, and so we're very pleased to be here this morning to be here with the Sierra Nevada Corporation, their Space Systems Division, to talk about a collaboration with them. Now, when you think of these Space Act agreements, basically, fancy name, it is just a small contract between someone and the government to do work, and it's a way for them to get to our capabilities. They're typically not large dollars, but they're very critical in that they give access. And I would equate it to, still like to work on my car, and sometimes I can't quite get it done, and I need a special piece of test gear that only the dealer may have, or I need a mechanic to troubleshoot it because I can't figure it out. I don't want to buy the whole dealership. I just want to go in and pay for them to help me a little bit so I can finish the job I started. Space Acts work the same way. Industry may have some need to get some technical consultation or ideas or a test done, and this is a way for them to come in and get that without buying the whole dealership. And so it's a critical transfer. The effort we're going to talk about today, and they'll give you more details on it, fits in with NASA's strong support of going with developing commercial space. From a Marshall standpoint, it's an important collaboration to reach out and work with industry in the U.S. and to let them have access to our capability. It's also critical, though, when we sign up to this, we're basically almost like a commercial company. We need to deliver what Mark Sarangelo needs and his company and get it out on schedule to help them do their job. Why is Marshall involved? Well, most of you know, especially if you're local, Marshall has close to 50 years experience in space doing design, development, and testing, and we've got a litany of skills from propulsion to space systems to life support, materials, advanced manufacturing. In this case, all the way back to Skylab, we have been working science and payload operations and integration, and so we'll talk about that a little more. The partnership opportunities when people come in to work with us, it could be anything from I need some time to get some technical consultation. Somebody may need to borrow one of our special machines for a few weeks to do some run themselves on, or they may want to hire us to do testing. And so things come in different ways, again, to be just kind of like the car dealer scenario, different needs, and you do it. Currently, we've got about 200 partners we're working with. And these ebb and flow, and they're always in flow, and so there's different work we're doing supporting the community. And again, commercial space is critical, and Sierra Nevada and their Dreamchaser is a critical part of that program. And so I'm pleased now to introduce Mark Sarangelo. He's the Vice President from Sierra Nevada Corporation Space Systems, and he'll talk some more about the activity. Thank you.
Well, thank you, Paul. Good morning, everyone. It's a real pleasure for me to be here. I was wandering around the mall and I ran into Paul, and he gave me help. So I figured it's the easiest way to get here. But it is really that kind of story. From our company, from my perspective, space is a team sport, and we're building the best America's team around this project that we can build. And that means going to people who have the expertise, the knowledge, and the ability to make us better. And really what today is about is that story. We're adding to our team, a team that has really grown and represents a substantial portion of the best of the space industry in the United States and beyond. And I wanted just to give you a little bit of insight into who we are as a company, our program, and this relationship and our partnership as we go forward. So before I do that, I want to recognize that beyond the people that are here, we are really have been expanding in Alabama, and we have a number of our other partners who are in the room or listening in today. Lockheed Martin, United Launch Alliance, and Draper, all of whom have presence here in Alabama. And we also have been reaching out to a number of other organizations here in the state: Cord Technologies, the University of Alabama in Huntsville, University of Alabama in Birmingham, as well as the Hudson Alpha Research Center. And this is a growing group of organizations who either are directly helping us or working on something that we think is important to our America's space future. And we'd like to thank them for being part of this as well and continuing the relationship with us. What I'd like to do for the next few minutes, if I could, is introduce our company a little bit more in detail and our program, and then we'll talk about the relationship and partnership. You know, one of the things I find every time I come here to Alabama is that there's a passion, and people come into this industry because we believe in what we're doing, and we think it's a wonderful place to be, but it's also something in our soul and our hearts. And one of my favorite sayings, if I was in heaven, I would do exactly what I'm doing now forever. And I think if you walked around the center here today, you would find many people that would relate to this type of feeling. And we try to see things from a little bit of a different perspective. One of my favorite pictures is this picture, which was the first picture of Earth taken from the moon by a human. And it really put our world in a different perspective in the 1960s. And we look at our program as really being something that looks at life from a different perspective, one that believes in partnership, believes in relationships, and believes in collaboration. We, as a company, some of you may know us, some of you may not. We're 100% owned by our management. We have close to 3,000 employees now, a little under $2 billion a year organization. Been profitable for a long time. We've been in spaceflight now over 25 years. And have over 420 space missions to our credit. About 4,000 things we've built for space, and so far, and every time I say this I have to smile, we've had no on-orbit failures, and we'd like to continue that way. This year we're going to be launching something that we've built every 3 weeks and have over 70 successful missions from NASA and operations and business in 20 countries right now. We represent a collective group of people throughout the United States. We have offices in 20 different states, 30 different facilities in the United States right now. And our product lines beyond space range from aviation. We're one of the largest converter of airplanes for the U.S. government. We have hundreds of planes that are in operation around the world right now. And in space we do 4 things. We are one of the largest builders of small satellites. We're one of the most significant builders of space technologies, essentially the mechanical and electrical mechanical parts that make many other spaceships work. We are a propulsion company. We're not a rocket launch company. We build motors that move things in space. And finally, what we're here to talk about, we're the owner, operator, and developer of the Dreamchaser, which is a LEO, low Earth orbit transportation system. Last year we celebrated our 25th year, and we went back and looked back and said, realizing that we've been to 7 planets with something we've built, the moon and the sun, and we've been to Mars almost a dozen times over our history. It's really quite a series of programs that we've been involved with, including most recently doing the birthing mechanism for the Orbital Science Cygnus program, a very successful program that has resupplied the space station. We've done a series of missions throughout NASA's history, several Mars missions, including the Mars Science Laboratory. We're on the Orion program. As some of you know, Curiosity last year or 2 years ago landed on Mars. We helped build the descent system that made that happen. One of the most significant moments, I think, in our history. And when you realize that you see pictures like this and you've helped do things like land a robotic exploration vehicle on Mars, you realize why this is such a great industry and why collaboration and partnerships are such a wonderful thing. We do a series of other missions for NASA, including most recently we're joining what is going to be a fascinating mission to study the sun from the most closest point that it's ever been studied from before. We're on several large programs for commercial satellite programs, as well as a number of U.S. government satellite efforts. Part of what we do is that we are very involved with most types of commercial space activities. This is a rocket motor that we build and test. It's our hybrid rocket motor. The motor is used not only on our Dreamchaser vehicle, but also as part of the Virgin Galactic program, which is the first commercial tourism program that is slated to start its operations this year. We're the main rocket motor provider for that program. And that program is now flying in test flight, and we're very proud to be part of that and part of the future of that sector of our industry as well. But mostly today what we wanted to talk about is our Dreamchaser. Dreamchaser is a program that actually started back in NASA. It was originally a program called the HL-20. In the 1980s and 90s, NASA was looking forward to building a crew rescue vehicle for the space station, and it designed such a vehicle. This vehicle had about 8 to 10 years of design work done, primarily at the Langley Research Facility and NASA's facility in Virginia. And then for a variety of reasons, including the space station going down to a much smaller complement of people, the program was put on hold. We took it out of the attic, as I like to say, or out of the NASA program office in 2004, and have been developing it as a vehicle since that point in time. It has, in our view, when we first started looking at this, we had really two goals in mind. One was that we realized at some point the space shuttle was going to retire, and having a lifting body space plane that could very much do some of the missions that the shuttle did, not all of them obviously, but many of them, would be a good thing to have in the American space fleet. This is a picture I like to use because really of two reasons. One is that while the size here is very different, we like to look at this as big brother, little brother in some ways, but we really understand that to really move forward in the space industry, you have to respect the past and you have to respect the people who have been in this. And I like to say publicly that 135 shuttle flights really have made us a better company, a better organization, and certainly I've learned a lot from it. And we're very proud to continue that legacy of what was done by NASA in the shuttle program in our minds. What we also like to point out in this is that if many people realize that the shuttle had a terrific job in building the space station and opening up low Earth orbit to research and development, we feel like we're continuing that on with our vehicle. And while these two vehicles are very different in size, we actually have similar space inside the Dreamchaser for cargo, for critical cargo and pressurized work for humans. And it's quite an honor for us to be continuing this program. Recently, some of you know that we were down in Florida and showing off the legacy a little bit. This is our model Dreamchaser next to the final spot where the shuttle Discovery landed. And we took this photo because we have so many people from NASA who have joined us. We're quite honored to have our program lead for Dreamchaser be Steve Lindsay and John Curry. Steve in particular, as we were looking at Discovery here, was a 5-time shuttle pilot, has over 1,600 hours in space, and led the NASA astronaut office for a long time. And now he and a terrific group of people are leading our Dreamchaser effort. And we do this because it is a blend. We think that it's important to take the best of NASA, the best of industry, the best of university, as well as what we can do as a company and put them all together and make a very successful program. If I'd like to give you a brief video to show you the reality of where we are with the program right now. Our vehicle is made of composite primarily, and that composite is put together to create one of the strongest space vehicles that's ever been built. As we developed the program, we developed a series of test vehicles before we built our first full-size flight test vehicle. In our world, this is the equivalent of our Enterprise as Shuttle did its work. That work was done using another NASA center. We brought it out to the Dryden Center in Mojave, which is where it did its several of its tow tests, ground tests, as well as captive carry and its first free flight test. Using, as we are talking about today, a partnership, a great partnership with NASA and Dryden, as well as the U.S. Air Force. We are quite fortunate on this on this effort for Dreamchaser to really be able to be building what we think is America's dream team for space. Currently, we have over 15 industrial companies, 7 NASA centers, and several universities as part of our team, and that is growing. And the philosophy here is really quite simple. We looked at this and said, if we can do it, if we have the ability internally to do it, then we might consider doing it. But if we don't, we're not going to build it. We're going to look to the outside and bring on the best of the best from industry to be able to help us. This has really been, I think, a terrific way for us to grow. We certainly have the best team in the country, and we now represent employment and suppliers in over 30 states working for the Dreamchaser program, including, obviously, here in Alabama. It's quite the collection, and when I travel around the country, I get to meet people who really are so thrilled to be part of the next generation of America's space program. It's really quite rewarding to see that. Recently, some of you may know that we were down in Florida making an announcement, and what you see here is the Atlas V rocket, which is the rocket that will be taking us to space on our human flights. In the background is the actual Atlas, and in the foreground is our vehicle standing on top of the rocket, as it will look in the future. And we were very fortunate to have Administrator Bolden there, as well as Bob Cabana, who runs the NASA Center in Florida, Steve Lindsay, and Michael Gass, who's the CEO of United Launch Alliance. That announcement was a critical part in our juncture, and one of the great things about doing this is that you spend a lot of time dreaming about what you do, and we're now in the phase of bringing that dream into reality. We made the announcement that we have acquired our first rocket to go to orbit, and that launch date will be November 2016. What's particularly critical, and I think is most important here, is that that is a multi-state effort as well. The rocket, the Atlas V, is built here in Alabama at the Decatur facility. And in our view, from the launch side, it's really a collective of being able to be designed in Colorado. The rocket is built in Alabama, and it's launched in Florida. And it's really, in my view, bringing American jobs, bringing jobs back to America, and really expanding our space industry. Our goal and our target here is currently the United States is acquiring all its human space flight from the Russian space program. And while that has worked well and there's been no issues, we think it's best to be able to bring those jobs, bring that money back to the United States, and bring those jobs back here to places like Alabama, and to allow us to move forward and fly proudly the work that we can build here in the United States. What you sometimes in life you get the opportunity to do something special. Certainly, flying space vehicles and building America's next human spaceflight vehicle is special. But even more than that, through a series of coincidences, we had our first flight on October 26th of 2013. That happened to be the exact time, hour, and place and location that the shuttle Enterprise finished its career of 5 flights. And it was really sort of one of those coincidences I couldn't have planned. It was aided in part by the government shutdown, and it just turned out that we wound up flying on the same day that
Glad we could help.
It's one of those things. We really do appreciate that support. But I put this up here because for us, it really is that. It was symbolic in a way that Enterprise was meant to fly and test the shuttle in atmospheric conditions, and our vehicle, this first vehicle, was meant to do the same thing. And as that program ended, we felt we were the torch was being passed, and we were picking it up and hopefully proudly carrying it to the future. We Sierra Nevada is here in Huntsville. We've been here since 2012. We are expanding our presence here. We're expecting a growth this year of about 25% in the local area, and we have multiple businesses here. We have our integrated mission systems business here, which does unmanned aircraft systems and supports that many programs in that area. We have a communication and navigation systems group here, which is expanding things like automatic takeoff and landing, and we now obviously are expanding our space presence here. So Huntsville is becoming a critical part of our future. What we're going to talk about today is really the missions, the potential missions, the growth of missions for Dreamchaser, and we look at those in really three different ways. Servicing in space, doing extended science in space, and being able to really understand and be able to utilize the technologies that are built here on in places like Alabama for doing research in low Earth orbit. And I'd like to stop there, and we'll be able to come back to the rest of this. But we are announcing today an expansion of our relationship with the Marshall Space Flight Center. We have been working together now for well over almost 2 years, and we really are looking to the future and saying what we can do together, how we can work together, how can we utilize the great people here at Marshall and the work that's being done, and really be able to advance the different mission concepts that we have for Dreamchaser. We're concurrently bringing on board and expanding our relationship with Teledyne Brown. And the rest of this conference is really going to talk about those two relationships, but they are really symbolic of our effort and what we're trying to do here. I'd like to start by introducing Teledyne Brown, and Rex, who's sitting here to my left. Really, there's no introduction necessary for this company. Back now over since 1953, elements of Teledyne have been doing work on our space program, and pretty much anything that has touched the space program this organization has touched. Really has been one of the premier engineering firms that has been involved in all the major historic movements forward of NASA and the space program, and we're so fortunate to be able to have them come on board and help us and move us forward. Most importantly, I think someone like Rex, who's given his heart and soul to this industry and is a terrific leader for this organization and really for our industry. I'm very proud to be able to have him join our team and to make sure that I stay online and kick me in the rear end if I don't. So, Rex, I'd like to turn it over to you, and maybe we can talk a little bit. Thank you.
Sure. Thank you, Mark. First, I'd like to thank, by the way, welcome, good morning to all of you. I'd like to thank NASA Marshall for hosting this event. It's personally and professionally gratifying for me to make connections back here in Huntsville, and I thought it was sort of interesting and coincidental to be sharing the press table with Paul Gilbert here. We talked about this last night, but Paul and I started our NASA careers almost exactly the same time. He was integrating missions for Space Lab, and I was trying to develop payloads for some of those same Space Lab missions, and it's interesting that common ground brings us back together here today. So good to be sitting here with Paul. And I wanted to thank Mark Sarangelo from Sierra Nevada for inviting us to participate in this event. I thought it was an especially generous gesture on your part, Mark, so thanks for having us participate in this exciting team with you. Mark and I met at the U.S.-German Aerospace Roundtable last fall in Germany, and we were both over there trying to build our international space portfolios, if you will, trying to establish some interesting relationships with the German space agency DLR. And so we find that we have some common ground in other areas as well. So thank you, Mark, for having us do this. There are two dimensions to our relationship to Sierra Nevada on this with regard to the Dreamchaser program. Last fall, we executed a teaming agreement with Sierra Nevada for the follow-on commercial crew program, which is still in competition. And per that agreement, we will be the preferred provider for the DreamLab science payload and cargo integration. And so we were very pleased to join the Dreamchaser team with some of the well-regarded companies that Mark already mentioned, and also some interesting university partners as well. And then second, we're engaged in the mission scenario planning and analysis through the Space Act agreement that Mark referenced earlier with the Marshall Space Flight Center. So they have a relationship to Marshall, we have a relationship to Marshall, and through that we're able to do some of this mission planning and mission analysis that will be interesting and important for the future of the program. Mark talked about it already in one of his charts, but we're looking at some very interesting mission scenarios, including performing science while docked to the space station, satellite servicing missions, sortie missions that do science independent of the space station. So this vehicle is capable of a lot of different interesting mission profiles, and we're helping to assess that and work through those scenarios with the company. It was mainly our rich history, it's already been alluded to here, but our rich history in payload development and integration that connected us to the Dreamchaser program. We do have a 55-year history in human spaceflight that goes all the way back to Explorer 1. Many of you in the room will know that NASA launched a satellite in January of 1958 in response to Sputnik. It was really, Sputnik is really what led to the creation of NASA through the Space Act. And Brown Engineering, as it was known back in those days, was involved in the integration of that payload. So our payload integration capability and history goes literally back to the very first U.S. satellite ever to be put in orbit, and we're proud of that fact. We've been working with NASA, NASA Marshall in particular, in this payload integration activity for all these years. We were involved with the integration and operation of over 20 different Space Lab missions that occurred between 1983 and 1998. We are the team with NASA that has performed payload operations, science operations on the International Space Station for the last 15 years. That's what we do. So payload operations, payload integration is really where we live, and we're glad to be able to translate that capability to the Dreamchaser program. And finally, I will offer that Teledyne Brown, I would say, and Teledyne largely embraces the particular kind of commercial business model that we see Sierra Nevada undertaking here with NASA. I find it easy to endorse a program that has a symbiotic nature to it, where we depend upon one another. I think Mark put it extremely well when he said space is a team sport. We believe that to be the case, and the challenges that are brought about by space require complex solutions, require integrated teams and great efforts, and so that's the way that we see this one going. To cite an example, Teledyne has a program, has a Space Act agreement actually with NASA to put a commercial space imaging platform on the International Space Station. We call that the MUSES program, where we'll be running a commercial business doing Earth imaging. We've built a ground operations center here at our Teledyne Brown site on 300 Sparkman Drive to take the data, to do the data analysis and distribute the data. And then we've talked with S&C about using that same capability on the Dreamchaser program. The point is that we're finding interesting ways to work together with each other, with NASA, and even with other governments like DLR to tackle the complex challenges that space offers to us. So again, very pleased to be a part of this event and part of this team, and thank you, Mark, and back to you.
Thank you, Rex. One of the reasons that we think that this is so important is that Dreamchaser has a lot of attributes, but it is a runway landing vehicle, and it brings things home from space with very low G-forces. What we do at the ISS, what we do in low Earth orbit, is really not observation right now. We're not there only to take pictures that people can see. We're there to do real science and real research. And being able to bring that real science home, bring it home to a runway, bring it home with the least disruptive force possible, enables that science really to move to the next level. And as part of this, as Rex mentioned, we're looking at how we can maximize the utility of the vehicle once we are starting to operate in low Earth orbit in a couple of years. We have had a similar wonderful relationship developing with NASA centers around the country, and here in Huntsville we started our relationship with the NASA Marshall Space Flight Center in 2012 when we started doing some really critical work with wind tunnel examination. Is the vehicle going to fly the way we think it's going to fly? And the terrific people here at Marshall helped us down that road, proved out our concept, and it began the road that we now continue on today. The data generated really enabled us to understand that yes, we can do this, we can fly, we can do what we need to do, and we were quite fortunate to have really the best people here at Marshall be able to work on that. As we continue on, we're looking at science missions for Dreamchaser, what we can do, and again, we think that the Space Flight Center here in Huntsville has a capability of taking us to the next level. Really, when you think about payloads, you really have to think about Huntsville and NASA in Huntsville. There's been now operations for well over 100 different instruments and many different programs here. And as we started looking at how could Dreamchaser be a supplement to what's going on in low Earth orbit, we certainly wanted to be able to have the best of that technology and the best of those people join us on this effort. Dreamchaser is a program that really we think is a continuation of not only what the shuttle was doing, but an extension of what we're doing on the ISS in low Earth orbit. So I'd like to turn it over to someone whose name I can't forget, since it's Mark, and have him tell us a little bit more about what we're doing here in Huntsville and his operation, and certainly the long history that he and the center has in reaching out in partnerships like this. Mark?
Yeah, thank you, Mark. I want to wish everybody a good morning. You know, as an engineer, it's always a good day when you get to work with highly motivated, highly innovative people like the folks at Sierra Nevada. The Mission Operations Lab here at Marshall Space Flight Center has a long history of being what I call science enablers. We're not the scientists, but we've done a lot through the years to really enhance and advocate for and bring home the science for a lot of scientists at universities and private industry and within the agency itself. This stretches way back. Space Lab was where I eventually got involved as I was coming along in my career, and we had a very successful program there that evolved into the International Space Station. The Mission Operations Lab really leads the payload operations integration efforts for the International Space Station, and provides really the mission planning and the overall goals, priorities, helps execute what happens in terms of science on the International Space Station. When you look at the Dreamchaser vehicle, she just begs the question of what more can she do. She's designed for the commercial crew, commercial cargo functions, but when you start looking at her, you think, okay, there are other things. And so Sierra Nevada has come to us primarily because of our long experience in enabling science and our understanding of the kinds of payloads we've seen through the years, the kind of capabilities that a vehicle will need, some of the criteria for different kinds of science missions, whether you're talking about microgravity science in the materials world or whether you're talking about life sciences. And so we're going to be working with them. It's really a team effort to define mission profiles that make sense for their vehicle and give them an opportunity to go back and really decide in the long run how they're going to outfit this vehicle for science, both in attached station mode potentially and in sortie mode. So that, I'll turn it back to you, Mark.
Thank you, Mark. As we conclude this, we'll open up for questions here in a second, but I'd like to just end by saying thank you to you all for showing up and for coming here and taking an interest in us. When I first started coming here, we noticed that the car's license tag said stars fell on Alabama, and I think we take that literally in space because we look at the stars a lot, but I think beyond that, it's more than just the thought of looking at stars, it's the people involved. And really what we are doing is bringing the stars of our industry together, and certainly Huntsville and the rest of Alabama is going to be a continued, really significant part of our program. And I'd like to extend my appreciation to my guests here and to NASA for hosting this and for all the people behind here, because it's really been a collective effort with the communications department as well. So we'll take some questions now.
Okay, and we just would like to thank our panel for talking to us today, and now we will open it up to the media that is here. So we'll take some questions from our media, and then we'll take a few questions from our teleconference line. So we will have a...
Hi.
Hi, Liz Hurley, WAFF.
Hi, Liz.
My question is for Mark. Welcome back to Alabama.
Thank you.
You talk about the Huntsville, the rest of Alabama being very key when it comes to economic development and scientific contributions. Can you go into more detail about how you'll be utilizing and what specifically you'll be doing in this partnership with UAH, with Hudson Alpha Institute for Biotechnology, and other local corporations?
Sure. I think just to start, we, as I mentioned, we're going to be building our rocket here, which is a big deal, and that's certainly an important element of our starting. But what we're looking at doing, the Dreamchaser essentially is, you can think of it as a mobile science lab, much like we have on the space station. It has the capability of doing on-orbit research in a variety of different ways, and we think one of the most critical ways to do that is looking at the whole bioscience area, to be able to understand things in space that we can't do here on Earth, and that is what's being done in part on the space station. But there are a lot of experiments that really don't need the long duration work that's on the station, or perhaps aren't best used on the station, so we think we can be supplementing that. what we found here in Alabama through the organizations that you mentioned is that there's a terrific knowledge base of already how to connect that type of research with the type of research we might do in LEO, and we're exploring how do we put those two together, how do we make that type of research enabled by the Dreamchaser and by what we're trying to accomplish. And the gentlemen here at the table and their organizations are really going to help facilitate the construction of what that might look like inside the vehicle, as well as then we're reaching out to the organizations saying what experiments might they be able to do if we had this capacity.
How many companies, though, and how many institutions are we talking about? Can you talk about that as well as dollars and people?
I really can't yet, Liz, and I'll be honest. We're beginning this dialogue. We are reaching out to the organizations. This is, I would consider this the kickoff point for what we're trying to accomplish. We could project, but then that wouldn't be honest. So we'd rather come out and say that we're starting the dialogue with these important organizations and really trying to look at what's the best way to move forward. Hopefully you'll come back to the next level of conference we'll have where I'll be able to outline those more in specifics. But really, we now are starting to fly the Dreamchaser. And once we start flying, we then can look at what else can we do, what missions can we accomplish, what concepts can we work at. And today's organization is to take us to the next level, both on the design of the vehicle as well as the beginnings of the relationships with what we can do on board.
Mr. Ramsell.
Yes.
David Wood with WHT 19. You talked about that innate sort of passion that folks in your corporation and here at Marshall and Teledyne Brown exhibit. And you know, for the non-space professional, for you know, the average Joe Blow, the average citizen who may hear commercial space, and, you know, commercial as opposed to what, or, you know, may not exactly know exactly what we're dealing with here. Can you explain why these days, you know, in an era where, you know, NASA is essentially having to validate themselves, and, you know, can you talk about why these collaborations are so important for not only just the continued mission and self-edification, really, but just for the next generation and for posterity, for the next generation of those who are going to continue what we want to accomplish here?
Of course, thank you, and thanks for the question. I think there's a couple answers there. Yes, it was a long question, so if you will, I'll take it in different pieces. To start with, I wanted to really congratulate NASA on having the courage to look at this differently. It's not easy for a government agency to look at the future and say we need to think about how we're going to work together. This is a public-private partnership, the program that we're involved in, and it's a unique one in many ways, and so far a very successful one. And we feel very benefited by being able to look at it that way. It is a true partnership. My inclination is to reach out to my partners in NASA and the companies that are working with us to see when we have something new to do, that's where we go first. But really, why are we doing this? We're doing this in many ways to stimulate the STEM education side of our country, to stimulate our thought process. Most of the people, if you talk to people in space, myself included, we got stimulated at one point in time. Something happened in our past that made us realize this is where we wanted to be. And part of our obligation as leaders in this industry is to look to the future and say, what can we do to stimulate the next generation of people, the next generation of kids? And if you see the children who come up to Dreamchaser and you see what they do when they look at it, I don't know whether or not they're going to build a better space vehicle than I do, but I do know that it's going to make them think about science and think about what they can do and how they can expand their minds. And that's part of what we carry with us going forward. And as we do that, I think we also look at and saying that our job here is, we feel we're part of a long-term partnership in NASA's future. A lot of people wonder where NASA's going. I don't. I think it's on a terrific track. We're very supportive of the Space Launch System, of the Orion program. Our job is not to go beyond LEO. Our job is to really look at low Earth orbit and try to provide the best transportation system and platform that we can. And in doing so, make as much of that based here in the United States and in our partner companies and countries as we can. And we think at the end of the day, that will make an opportunity for those students who are on board now. We have one of the things I like to talk about, we have a really active internship program. We're going to be bringing people from Alabama on board as interns in our program. And I used to think that we were giving them an opportunity. And then they show up, and then you realize that what they're really doing is they're stimulating the people like me in this industry. And we really just are very fortunate to be able to help move that next generation along. So hopefully that answered your question.
Okay, do we have other questions?
Mark, how will you go about soliciting and exploiting the things that Dreamchaser you believe it can do on the scientific realm?
Well, what we tend to do is start looking at the basic capabilities and see what can grow off of those in terms of some potential science, types of science. There's when you look at space station, you have things like material science furnaces, you have things like glove boxes, we have an express rack which gives a standard interface for different flavors of science, but they can use that same common interface for a rapid integration. So I'm anticipating that the Dreamchaser will lend itself to some of those concepts. And then when you look at actual mission requirements, you know, some missions, microgravity kind of missions, want very low disturbances. There's things that Dreamchaser could do in a sortie mode, uncrewed, that could give very low disturbances for payloads that need, you know, a short duration flight but low microgravity. So it really starts with assessing, you know, where the design is today, looking at what we've learned from space station, look at our best practices in terms of payload integration, and really just talking and conceptualizing with the team on you know, what it could potentially do.
Okay, so now we're going to take a few questions from our teleconference line. So we will open it up. Camilla, if you would put through the first question that we have, and I'll put the microphone down so we can hear it.
No problem. Thank you so much. Today's question and answer session has begun on the phone line. If you have a question on the phone line, press star then 1 on your touch-tone phone, and you'll be queued up for your question. Once you are queued up, just record your first and last name and your media affiliation, and you can go ahead and queue your question up. And again, if you have a question on the phone line, press star then 1 on your touch-tone phone, record your first and last name and your media affiliation. And at this time, we'll wait for our first question.
Okay, thank you.
Nothing.
It's how you know you've run a good press conference. Go ahead.
My question
Yes.
is, now that I have a panel of experts in front of me and in this room, for the last 5 days, the world has been watching Malaysia and the airliner there, and no one can find it. Has NASA, and Rex, with your expertise with NASA, has NASA been asked for any of its assets? It certainly has some that can perhaps contribute to the location. Or is there anything with Sierra Nevada, is there anything technologically out there that hasn't been tapped to help find this aircraft?
So I'll take a crack at that, Liz. I don't know the answer to the question since I'm no longer inside the government, but there's certainly a variety of U.S. government assets that could be brought to bear there, and I would be surprised if they haven't been.
What would those be?
Well, satellites and things like that, imaging systems that could see debris in the ocean or something like that. But and I'll be surprised if they haven't been scouring just about all the commercial and all the government imagery that's available to see if they could find anything.
That kind of request would typically come in at headquarters somewhere, so from the center perspective, we haven't heard it, but it would come in, and like Rex said, it would probably go to one of the satellite divisions, like the Science Mission Directorate or someone, but that would be worked at headquarters, and so we don't have any knowledge of it.
Well, I had a question, for instance, like with Severe. Severe was able to see so many interesting things with the Mayan ruins, and that was in a low depth. I thought, well, this is a low depth area. Is that something that one could possibly think about another application?
No, you absolutely could, and that's the correct analogy. And in the case of Severe, what they're doing is they're tasking either commercial or government satellites to produce that imagery for them. And so that's exactly what you do. Put a request in, see if you can find an image that's relevant to it, and hopefully find something. And I'm very certain they're doing that.
Is there anything with any of your jobs that they're looking for technology now that can actually be put on a commercial airliner like this, so it can be located?
Not that I'm aware of.
Not directly. So,
Okay.
so if we have no other questions, then we'll close it out. But are there?
I think we do have
Okay.
one on the phone line. So we'll take our first question from the phone line.
The first question comes from Al Schrader, independent inventor. Your line is open.
this is Alfred Schrader.
Hi, Albert. It's Mark Sorangelo. How are you?
Yeah, Mark. I'm down here in Florida, actually. I'm right directly from the Kennedy Space Center, as it is. One thing I'd like to say, it's a beautiful day here. It's amazing. But anyhow, the Dreamchaser is using a new fuel system, that butadiene and nitrous.
Okay, can we get you to ask your question again, please? Your volume wasn't very good.
Is it too high or too low?
Needs to turn up just a little bit.
Okay.
There we go.
There we go.
The Dreamchaser is using what in our industry is a relatively new fuel system, the butadiene and nitrous. Can you explain how that is different and how it works?
Sure. There are a couple elements of the Dreamchaser's propulsion that I think are notable. The first is that we have no hazardous materials on board. This is, as far as we know, the first human spaceship that has done that. We use a main propulsion system that uses nitrous oxide, which is laughing gas. It's what your dentist gives you. The fuel is a derivative of rubber, and it's quite safe and quite stable. And the system that we use to do small movements in space, which is a reaction control system, uses an ethanol-based fuel. So between all those, essentially what that means is that the Dreamchaser has no hazardous materials, and that really helps us in two important ways, three important ways. Besides being very safe and stable as a flight vehicle, it allows us to, when we land, go right up to the vehicle. Unlike the Space Shuttle, which had a lot of poisonous materials and had to be safed, we can actually go right up to the vehicle. Much like if you go up to a regional jet, you can put the stairway up and take the people off and take the critical experiments off. So if you can imagine, if we're bringing home an astronaut who isn't well, or if we're bringing home a very critically time-sensitive experiment, the ability to do that allows us to move as rapidly as possible. The other interesting feature is that we are able to land at any commercial airport. And we are looking at whether or not we want to do that, but the vehicle has the ability to land basically any place a 737 can land. And as we look forward to how we want to operate what we're doing with the vehicle, sometimes it may be very important to bring those experiments back as close as possible to where they need to be analyzed. Thank you, Albert.
One other question I've got is, unlike the shuttle, which you're pretty much committed on your landing, can these engines be restarted?
They can be restarted in space, but they're not. We're not going to be restarting them on the return trip home once we've committed to coming back. So we are able to use them in space as restartable, throttleable motors, and what that allows us to do from a scientific point of view or from a repair and construction point of view is to potentially conceive different missions at different places in orbit from the same flight.
Well, that's pretty good. Well, thank you very much.
Yeah, thank you.
Okay, so do we have any more questions? We'll take one more if we have any others in the audience. Okay, so...
Well, thank you all for coming today.
I'm on the phone line.
Okay, one more. Okay, Camilla, I think your person may have gotten lost. So we're going to go ahead and conclude the press conference. We would like to thank our panel, Paul, Mark, Rex, Mark, thank you all so much. We would like to thank all of you for coming, our media, and that concludes today. Thank you, everybody.